In the landscape of modern technology, few ventures capture the collective imagination quite like Neuralink. The company, co-founded by Elon Musk, is dedicated to developing brain-computer interfaces that promise to bridge the gap between human thought and digital systems. While the notion of a neural lace or brain implant still sounds like the stuff of science fiction to many, Neuralink's research indicates that we may be on the brink of revolutionary changes. Changes that will reshape healthcare, communication, personal capabilities, and even the nature of human consciousness itself. This video explores how Neuralink could alter our lives in the near future, covering everything from treating neurological disorders to eventually blending human minds with artificial intelligence. One of Neuralink's central goals is to establish a direct connection between a person's thoughts and digital devices, smartphones, computers, and potentially any system controlled by electronic signals. At first glance, this might just sound like a faster way to type messages or scroll through social media. However, the broader implications are staggering. Imagine being able to operate your laptop as naturally as you move your hand, or consider controlling apps and games using nothing but your intent with far greater precision than touchscreens, mice, or keyboards allow. Our current ways of interfacing with technology, tapping on glass screens, pressing keys, clicking buttons, are indirect. They require motor actions, which in turn require muscle movements. Neuralink aims to eliminate these steps by tapping directly into the brain's neural signals. The first products focus on reading the electrical impulses in specific regions of the brain, such as the motor cortex, allowing them to interpret and execute user intentions in real time. Initially, we might see this technology used to help those who cannot use standard interfaces. Think of individuals with severe paralysis, for whom direct brain-to-computer interfaces would be nothing short of miraculous. Over time, as the technology improves and becomes more affordable, we could see widespread adoption, where controlling your phone, computer, or even home appliances with your mind becomes routine. Neuralink's mission goes beyond convenience and performance. One of its most transformative applications lies in its potential to treat neurological disorders such as Parkinson's disease, epilepsy, and traumatic brain injuries. Parkinson's involves the progressive degeneration of neurons in the brain, leading to tremors, rigidity, and difficulty with movement. Traditional treatments include medication and sometimes deep brain stimulation, which can mitigate symptoms but often with side effects and incomplete relief. Neuralink's more advanced BCI could, in theory, deliver electrical signals to specific neurons to restore normal brain function, or at least improve symptom management. This isn't entirely unprecedented. Deep brain stimulation already works on similar principles, but Neuralink's device aims to be more precise, less invasive over time, and capable of bidirectional communication. Seizures happen when groups of neurons in the brain start firing abnormally. Neuralink's interface could detect these early firing patterns and deliver a corrective electrical impulse to halt the seizure in its tracks. The prospect of a real-time, personalized epilepsy management system, one that constantly monitors brain activity and responds instantly, offers tremendous hope for millions of patients. Beyond specific disorders, the real game-changer might be the capacity to detect early signs of neurological decline. By constantly measuring brain activity, the implant could help catch diseases like Alzheimer's far sooner than traditional methods. Early interventions could then be applied to slow or mitigate the progression of these conditions. Today, people with paralysis or limb amputations often rely on complex prosthetics or assistive devices that still demand external or residual muscle function. With Neuralink, the idea is to link the user's actual thoughts to these prosthetic limbs or exoskeletons, bypassing damaged nerves or missing limbs altogether. For individuals with spinal cord injuries, the brain still sends signals meant to control limbs, but these signals never reach their destination. Neuralink could read these signals directly, interpret them, and convert them into commands that move robotic limbs or muscle-stimulating devices. This could potentially restore a form of walking, grasping, or other movements, dramatically enhancing quality of life and independence. One step beyond prosthetics is the exoskeleton, a wearable robotic frame that moves in tandem with, or on behalf of, the user. Instead of tiny muscle twitches or manual controls, the exoskeleton could respond to pure thought, offering a more fluid and natural user experience. Over time, the combination of advanced materials, AI-based control algorithms, and direct neural inputs could reinvent what it means to have limited mobility, turning it into a solvable engineering challenge rather than an insurmountable medical one. Who wouldn't want the ability to learn faster, remember more, and process information as efficiently as possible? Neuralink envisions a future where you could potentially boost your cognitive abilities with an implant. Memory is a complex phenomenon involving multiple regions of the brain. Although we're far from fully understanding how it functions, the principle that specific neural patterns correspond to memories is well established. In the far future, Neuralink-type devices might offer ways to record and replay these patterns, leading to sharper recall, or even the ability to share memories. Because the implant could theoretically communicate with external databases or AI systems, it may enable a two-way transfer of knowledge. Picture an instant tutorial or direct knowledge upload, reminiscent of science fiction. While we're not going to master advanced calculus overnight, consistent incremental improvements, like interactive tutoring powered by real-time neural feedback, could revolutionize education. Cognitive decline with age is a real challenge, one that not only affects individual lives, but places enormous strain on healthcare systems worldwide. As with monitoring neurological disorders, a Neuralink device could track changes in brain activity and implement subtle adjustments or even therapeutic stimulations that help maintain cognitive function. It's not an overstatement to suggest this might be a huge leap in geriatric care, drastically improving quality of life for older adults. Neuralink's website highlights ongoing research into using brain implants to restore lost senses. Vision, hearing, speech, and even tactile sensations rely on intricate networks of neurons receiving and interpreting signals. If a specific neural pathway is damaged, or a sense organ itself is non-functional, an interface could theoretically bypass these broken links or organs, and feed sensory data directly to the appropriate brain regions. For those who are blind due to optic nerve damage, a neural implant could take video signals from a camera and convert them into signals the brain interprets as vision. Though the image might initially be rudimentary, pixelated black and white for instance, it would represent a monumental breakthrough. Over time, improvements in sensor resolution and neural encoding could yield near-natural vision. Individuals who have lost their ability to speak due to strokes, ALS, or other conditions might use an implant to translate their intended speech patterns directly into audible words via a connected device. This concept goes beyond the common text-to-speech approach, aiming to tap into the brain's own language production centers. The result could be a fluid, natural-sounding voice, even if the patient's vocal cords themselves are paralyzed. One of Elon Musk's more controversial ideas is achieving symbiosis with artificial intelligence to ensure humans remain relevant in an age dominated by increasingly powerful AI. While some critics argue that we're nowhere near needing to merge with AI, Musk believes that the best way to prevent humans from becoming obsolete is to augment our own intellectual abilities. Neuralink sees its brain-computer interface as a potential gateway to such augmentation. As AI becomes ever more integrated into work, transportation, healthcare, and other domains, concerns about job displacement and losing control to autonomous systems grow. By bridging the gap between human minds and AI, Neuralink posits that we can keep humans in the loop, not as passive operators but as empowered collaborators. A practical example of soft symbiosis might be real-time language translation in your head. If your Neuralink could connect to a powerful language model, you could instantly converse with someone in another language, hearing your own words come out in French, Mandarin, or Swahili, and understanding the responses without conscious thought. This isn't just a neat trick, it fundamentally changes how humans interact and share ideas on a global scale. Tesla, another Musk venture, is developing a humanoid robot called Optimus. Neuralink and Optimus could complement each other perfectly, you think? It acts. While controlling prosthetic limbs is already a near-future goal, controlling fully-fledged robots that share your sense of agency extends the realm of possibilities to tasks once deemed too dangerous or demanding for humans. Imagine a scenario where you physically remain at home, but your Optimus robot is out in the field, repairing power lines, stacking boxes in a warehouse, or performing routine maintenance on infrastructure. Your neural signals guide its movements as if you were doing the work yourself, This could drastically reduce workplace accidents and open up new job sectors that revolve around telepresence through robotics. Robotic limbs, and eventually entire robotic forms, directed by Neuralink-like interfaces, may also revolutionize surgical procedures, physical therapy, or even teaching. A specialized surgeon in one part of the world could operate on a patient remotely, controlling a robot in a distant hospital with near-seamless precision. Teachers could physically demonstrate complex tasks across the globe. Though these ideas are ambitious, they reflect the transformative potential of combining advanced robotics with BCIs. It might sound flashy, but Neuralink's capabilities hint at the dawn of cyborg superpowers. If human beings can seamlessly control robotic limbs, see in spectrums beyond normal human vision, amplify their memory and processing capabilities, and self-regulate their emotional states, what does that make us if not enhanced humans? While the idea of superpowers can appear sensational, it also touches on a deeper conversation about inclusivity and accessibility. Historically, physical and cognitive disabilities have been limiting factors in personal and professional life. Yet technology continuously redefines these limits. Prosthetic limbs, for instance, are no longer just replacements, but can be optimized for sports. If Neuralink helps people with paralysis to walk or individuals with blindness to see, does that also open the door for healthy people to surpass natural limits? With great power, as the saying goes, comes great responsibility. The concept of physically or cognitively enhancing humans raises questions about equity, consent, and potential misuses. Who gets access? Will enhancements be so expensive that only a wealthy few can afford them? Societies might need to grapple with a new wave of bioethical questions similar to those stirred by genetic engineering or doping in sports. According to Neuralink, one of the project's core design philosophies is creating a BCI that is fully implantable, cosmetically invisible, and wirelessly powered by a small battery. This contrasts with many existing brain-machine interfaces that rely on wires protruding from the skull or bulky external units. In day-to-day life, any advanced piece of technology tends to succeed only if it's convenient and aesthetically acceptable. Neuralink hopes to make the device so discreet that casual observers wouldn't notice you have a brain implant. Imagine a small puck hidden under the scalp, connected to ultra-thin, flexible threads embedded in the brain's tissue. The device would communicate with external systems via Bluetooth-like signals, and a simple nightly charge might keep it powered. A critical aspect of this design is safety and ease of installation. Neuralink intends to use a surgical robot to precisely place each thread, reducing the risk of bleeding or infection. While no invasive procedure is without risk, the ultimate vision is an outpatient surgery that could become as routine as LASIK eye surgery, dramatically lowering the barrier to widespread adoption. As with all visionary projects, Neuralink faces significant hurdles: scientific, regulatory, and ethical. Brain function is extraordinarily complex, and while we've made leaps in neuroscience, we're still far from a comprehensive map of how each group of neurons encodes thoughts, memories, or sensations. Moreover, any device placed inside the human body must undergo rigorous safety testing and clear significant government regulations. There will be concerns over data privacy, hacking, long-term health impacts, and the unprecedented nature of intimately merging biology with advanced, silicon-based systems. Neuralink has already demonstrated prototypes in animal studies, such as a monkey controlling a video game with its mind. If these early successes translate to safe, effective human use, the potential benefits, curing blindness, reversing paralysis, elevating cognitive function, could drive massive support for the technology. And while many fear the possibility of AI overshadowing human intelligence, Neuralink offers a bold counter-narrative, a future where we integrate with AI rather than being replaced by it. In the span of a few decades, humanity has gone from marveling at desktop computers to being inseparable from smartphones. Neuralink suggests we might be on the cusp of an even more dramatic leap, making digital connectivity an integral part of our biology. This leap won't come without challenges. Ethical debates, regulatory scrutiny, and technological breakthroughs are all part of the journey. However, the rewards could be extraordinary. Patients with neurological disorders living healthier, more autonomous lives, Amputees and the paralyzed regaining mobility through mind-controlled prosthetics or exoskeletons, students and learners benefiting from immersive, interactive, and highly personalized educational tools. Everyone gaining a deeper synergy with AI, preserving our place as active creators and innovators in a rapidly changing world. Ultimately, Neuralink represents not just a startup or a single scientific achievement, it symbolizes a broader frontier in the human story. Like the printing press and the internet before it, brain-computer interfaces have the potential to reshape societies, economies, and the very definition of what it means to be human. Whether you approach it with awe or skepticism, one thing seems certain: the future holds surprising possibilities, and Neuralink's research may well be the key that opens the door to that new era. If this video got you thinking about the incredible possibilities and challenges of merging the human brain with next-level tech, you're in good company. The journey is just beginning, and there's so much more to uncover and discuss. Before you go, be sure to hit the like button and subscribe to stay informed about the latest innovations shaping our world. From AI breakthroughs and robotic marvels, to the cutting-edge frontiers of neuroscience. Your curiosity and support help drive the conversation forward, and together we can keep an open mind about the world-changing ideas coming our way.